Hello, John Anderson here. I'm doing this on Zoom. Did a test run and it worked, so hopefully this turns out and I don't waste uh, 10, 20 minutes of my time trying to record something that doesn't record. Hello again. Here I am in my house talking to a computer screen. Haven't ever really done this before, but good to not meet you all, but thanks for watching. And I hope to talk to you guys in person soon. So yeah, I made the Python notebook, and I'll share my screen here and just try to go through this a little bit. I think this is all pretty tough to do in terms of for someone who has no coding experience and no Python experience. It's kind of an uphill battle. It's not something you can pick up overnight or in a day or two or anything like that. But if you have some basis for it and a good brain for it, I think most of us do, being kind of analytical based thinkers, right-brained or left-brained or whichever one it is. But the interest is the most important thing, and I think if you're really interested and really want to learn, you can do that. And obviously, there's tons of resources online. That's how I learned it. I did go to school for data science, but I taught myself Python over probably a 3-4 month span, just using YouTube videos and testing around myself. I did have a coding background though, so that did give me a little bit of a jump start. I majored in computer science, and I knew Microsoft PowerShell and Java and things like that. So anyway, I think Python is written in a way where it's more or less in English. So just looking at the code, you can kind of tell what it's doing in a lot of cases just based on what the words say. It's not just random symbols or anything like that, and you'll see. But the best way that we should do this in a way to avoid having to install Python or anything on your computer, because that gets pretty complicated. It's this website called Google Colab. I think I'm going to sneeze here, so I'm going to have my cursor on the mute button there if I do. So maybe I'm okay. So this is a subset of Google where it's just a notebook environment where you can run your Python code right there. You don't have to install anything. All you need is a Google account. And you can hook up your Google Drive right to it to save off files and import data files and things like that. So for example, this first part we'll look at is just going through a fan graphs table with all so if you would go to a fan graph leaderboard and export that to CSV and put it in your Google Drive, you could import that right here and do things with it. And that's essentially what I did here in the first part of this. So colab.research.google.com, sign in, and you can make your own here. And I think you should even be able to, if you're looking at mine, I'm going to share the link, you should be able to save a copy to your drive and just open this up and make a few edits to reference your own Google Drive and things like that, and then run this all yourself so you can get started right away. So I'm not going to read this to you or anything. You'll have your own time, but essentially Python is just a basic coding language that is used for a lot of things. In our world, we're just going to focus on basically using it like Excel, Microsoft Excel, just getting tables of data and doing things with them, creating tables of data from the baseball Savant data set. That's kind of the end goal, and that's what we can really use for the website to come up with unique content. Making our own data files that, most other websites are just relying on fan graphs or baseballsavant.com and things like that. And you can get a lot from those sites, obviously, but you can go a lot further when you can kind of get an idea in your head, some data that you can't find, make it yourself, go find it yourself, and the pitch-by-pitch data set. So anyway, here's the beginning of it. First, this is kind of house cleaning stuff. You don't have to worry too much about this. These are just packages we're going to use. Python uses these packages, which are just pre-written codes that when you install Python, and again, Google installed this, it's on Google servers right now. We're not using our own computer resources at all. So this is all set up. We just have to import. So this line here, import pandas as PD. So pandas is it's like an Excel package where it lets you do a lot and lets you make and edit and modify and do all things with data frames, which are just tables. Just imagine an Excel table. So we'll be using that, and you'll see that going forward. But the rest of the stuff is just other packages that we'll use. For your purposes, if you're following along in your notebook, just copy this and run the cell. So that's how you run the code. This box above here is obviously just text that I wrote, and then these code boxes are where you put your code, and then to run it, to actually process the code, you hit the play button there. So in this case, we did install PyBaseball, which is a package that someone else wrote very nicely in Python that goes to the Baseball Savant API, and you can download all the Savant data right there without having to do any exporting it yourself. And so we will eventually get to this, but the the Baseball Savant data set is, there's one row for every pitch thrown in every season since 2015 or something. So if Shane Bieber throws a 0-0 fastball for a strike, there will be a row for that with 90 some different columns on it. So it's just a massive data set. It tells you everything that happened in the game, everything that the StatCast captures, and all this stuff just in one big table. But first, we'll just get into the Pandas basics, because that's the core of what we're going to be using, is this package to get tables and data frames. When I say data frame, it's just a table. Those two terms are interchangeable. Here's a little tips on how to link your own Google Drive to this. We won't focus on that now. So I already have a big data set in my Google Drive. I generated this from Fangraphs. I actually used Python code to go get all this and put it together, but maybe that's for another time. So with this line of code here, I'm just taking this table. Let's see, I'll show you what it actually looks like. So this is what I'm importing. This is it in Excel format. This probably makes a lot more sense to you. This is just a row for every player season I have from 2015 to 2020. So these are the last 6 seasons of data. Not everything from Fangraphs, but all the things I found useful. So a pretty big file here. You can see there's 50 some columns, so maybe 60 or 70, but so that's what we're importing here. That's what this line of code does. So it just puts all of that table into a variable called data. So now that whole thing we were just showing in Excel is all under this data name. So we can look at the column names, and we can see the same thing we were just looking at. So you first reference what it's called, data, and then dot columns. That gives you the column names. Now, of course, you can't really do much with that just looking at it all at once. So you can filter down. You can this is a way to filter. So you put your data, whatever you called it, above, and this might change. You can call this whatever you want, but then you replace that here. And then inside these brackets, this is where you do the filtering. So you say, show me only the rows where the name column has Mike Trout in it. So that shows you what we just did in Excel as well. It obviously still gives you every single column, and it's not very pretty to look at. If you're just curious about his triple slash line, say, you can add, so this is the same base code there, but I added on this little bit here at the end to just show me these columns. You can put whatever column names you want in there. If you put one in that type it wrong or something, it'll give you an error. So you have to actually name them properly, call them properly. So that'll cut it down. You can kind of see, just see the subset you want. You can sort with this. So I'm sorting by average, and I want it to be highest to lowest. Ascending equals false. If this said true, it would go the opposite order. So you can see Mike Trout's 315 batting average of 2016, and then all the rest. If you want to see, which players hit 50 or more home runs, here's the 3 that have happened since 2015. That was with this parameter. Just give me the home run values that are greater than or equal to 50. You can do 2 things like that. You can say, give me rows where the player scored 110 or more runs and drove in 110 or more. And then again, this is just showing those, without this, if we don't put this Well, in the end there, it's going to show us every bit of data, which since we're curious about runs and RBIs only, we can filter it to that. So basic filtering stuff, and this is all best if you're interested in this, and this is a good fundamentals to have, and that's all documented in these resources. And that's really, if you're serious about it, you're going to have to watch a lot of YouTube videos and do things like that. I'm not going to be able to teach. I don't think I'm the best teacher, and I certainly don't have that much free time to do that. But I do think it's good, you know, when you go onto those resources online, you'll see basically they'll show you examples just with like random numbers or other kinds of, you know, stock market data or something like this. So I think it's best to, since we're interested in baseball data, it's best to practice and learn things with baseball data. So that's kind of how I did it. I just always use Fangraphs data to learn this stuff, and it makes a little more sense when you kind of know the data and you know what you're looking for already. So grouping, maybe I'll just leave the rest of this for you to read. It's pretty it's explained pretty well here, and I think it's a little bit redundant if I go through it here, but just basically you can group by a certain column. You can say, show me the total home runs for each team in the data, and it'll find every single team in there and sum up the home runs, things like that. Some plotting. This is a bad one that I explained, an issue that you'll run into and how to fix it. So, I mean, right here, this is really what we're going to use a lot is plotting and visualizing the data, right? And it's that simple. It's in one line. You say, I mean, you have to clean up your data first of all. So like in this case, I was looking at the relationship between ground ball percent and fly ball percent, which is obviously a linear relationship because those two are opposite things. They're pretty much perfectly correlated. But first I wanted to get rid of any hitter that only had less than 200 plate appearances, right? So you want to do things like that. You want to filter out the weird small samples and things like that, and then make all the numbers numeric. You can read about that here, but basically when I imported this data, every value had a percent sign on it. So it'll say 43% sign, and the computer sees a percent sign, it knows that's on a number, and it can't read that as a number. I don't know what number. The computer says I don't know what number 43% sign is. So I had to go get rid of those percent signs and replace it with nothing. So it's just the number there, and then use the toNumeric function to tell the computer this is a number, treat it as a number. And then after you have it kind of cleaned up, you can quickly just do a plot like that. I told it what I want on the x-axis, what I want on the y, and you can see that perfect, pretty perfect linear relationship. Of course, there's line drags in here too, which skews things. If everything was classified as just a ground ball or a fly ball, you would see this as a perfectly straight line. But you can't have a 60% ground ball rate and a 50% fly ball rate. That's impossible, right? It has to add up to 100. Well, ground ball plus fly ball plus line drive has to add up to 100%. So any values up here would be impossible. Same with down here. Here's an example of a histogram, just looking at the batting average distribution for all players with over 200 plate appearances. So you can see that most hitters hit around 250 to 260. You know, these four bars encompass about from 245 to maybe 265 or so, and most of the data is within that. And then your top hitters are pretty much topping out at 350. Stuff you know, but good things to visualize and show. Now for the baseball Savant data, there is a really nice package that we talked about a little bit just to bring in the data. So when you make your own notebook here, you can just run this cell. Don't worry about the code of it. You will just need to change this line. You'll read that. I'm not going to go over that, but basically this cell of code here will bring in that whole data set, every row, just from the API without you having to do anything. So that's nice. So, but once it's in, you can see this is going to be the shape of the data frame. So this right here means that after you import this data, that this is every single pitch thrown last year. with 91 different columns. So there's 263,584 rows, each one row meaning one pitch. So there were that many pitches thrown last year, all quantified in this data with 91 attributes of it. So, I mean, just enormous. It's too big to open in Excel probably on your computer. So that's kind of a limitation. And it's really intimidating when you look at it just because of how much there is. And if you don't know what the columns mean, obviously you can't, you're going to have trouble getting anything done with it. There is this great resource here that has every column name and it tells you what it means. So I would definitely bookmark that and give that a look. But the one thing we'll use launch speed just as our examples here. You can see that column, that's a column name. So in this column in the table, for every ball that was put in play, it has the launch speed number. So we'll be using that. Here's a list of all those columns. Basically everything that you could imagine wanting to know is in here. And then we'll do just do one example and then I'll end the video because I think this is going to be a pretty large file that I don't know if my hard drive even has space for. So, so the batter name column is where for every row it says who's batting. So right here, I want to make a new data frame called Soto. I want to filter out every row, make a subset of this data that is just all the rows with one Soto as the batter. So you click that, we run that shape file again, you can see that Soto saw 827 pitches last year. That's what that means with that same 91 attributes. So it's still 91 columns, but we're down to 827 rows because that's all of the ones where Soto was batting. We can sort it to be chronological. So we sort by game date first, then the inning, and the pitch number of that inning. And that gives us, that puts it in order. So the first row of the data now of this Soto data frame is the first pitch he saw last year, which was a slider from Rick Porcello, which he took for a ball. You can kind of see how this works now. This is a super subset. I've restricted those 91 columns down to just 7 to show you what's going on. So this first row, Porcello threw him an 0-0 slider. He took it for a ball. Second pitch, he threw a 1-0 changeup. He took it for a strike. Next pitch, you can see how the count updates. So the ball goes here, 1-0. Then a strike, 1-1. And then he took another strike on a sinker. Then he took another ball for a sinker. So he had a 2-2 count, and that's when the at-bat ended. He was given a changeup, and he doubled on it and drove in a run. Obviously, there's way more columns here. There's one that will tell you the whole thing of what happened. It'll say one Soto doubled on a scoring Trey Turner or whoever it was. And then his second at bat, you can see it jumps right to there. So this came in against Rick Porcello again a couple innings later. He took a curveball for a strike, then a slider for a ball, then he hit a slider for a single. So that's basically how it's set up. If you sort it and filter it, you can kind of see an actual at bat, but you have to do a lot of filtering and sorting because there's so much in here. Now, if we want to look at his launch speeds, this is the column for launch speed. So I'm just showing here, show me the Soto data frame I made and just show me these 3 columns. And the dot head here is just going to show us the first 10 rows. If we don't have that, it'll show us like the first 10 and the last 10. So just showing the first 10, you can see the events is what the result of the play was. So if you take a ball or take a strike or foul one off, you're going to see this NAN, which means not a number, I believe, but that just means it's not applicable as well. There was no event because he just took, this is the same row. He just took a ball, so nothing happened in terms of ending the play, and he obviously did not put the ball in play, so there's no launch speed. But on his double here, you can see he hit that ball at 101 miles an hour. So the launch speed column is where you get your launch velocities. Now, if we wanted to, so in this case, we don't really care about these because they're just these rows aren't giving us anything. So we can drop the NAs, and that's what this little function does. We say drop all the NAs just on that launch speed. And I'm making a new data frame here. Note that because I don't want to take anything away from my base data frame. So I want to make a copy of this basically, but just drop all of the pitches where he did not put the ball in play. So filtering that out, then you can see these are restricted to just the rows where we had a launch speed. And these NANs here, these are foul balls. So they did not end an at-bat. Obviously, an at-bat continues to progress after a foul ball, so there's no events. So if we wanted to only look at balls where he put them in play, we would want to drop the NANs on events as well. And here you go. So here are his first 10 at-bats, his first 10 balls in play, put into fair play, and their launch speed. So you can see doubled, singled, made a few outs, hit a home run on a 99.7 miles per hour launch. We show this again. This is his distribution for all his launch velocities last year with a histogram. This is his hardest hit ball, 113 miles an hour. Looks like he hit 2 in that bucket. If you don't know what a histogram is, you give that a quick Google. Pretty easy way to see a distribution. This one I excluded the foul balls, so it looks a little bit different. And then here, if you want to just summarize a column, you can use this to scribe. So I say, give me the data frame I have of all of Soto's balls in play. I want to learn about the launch speeds of them. Tell me the description of that. This is where you see the mean, the minimum, the maximum. This 95.2 is actually the median. So that is just this histogram, but in number form. And if you know any basic statistics, you'll understand all of that. Here's another way to show the mean and the median. And maybe one last thing I'll go through. So another way, thing that you might be interested in is looking at pitch distributions for here. So what we're doing here is making a new data frame with just Shane Bieber pitches. And then this line of code says, look at the pitch name column and just count them up. And it shows you he threw 463 four-seam fastballs, 325 knuckle curves, etc. This is a way to turn that into a usable data frame. So actually do stuff with that. I did a little bit of math to calculate the percent share of that. You can see the four-seamer came at 37%, 26% in the curve. Then we can do the group by. If you read this, you'll kind of understand this a little bit better. We kind of skipped over that. But this function, it just says go find, for every pitch you threw, find the average release speed. That's the velocity of the pitch. And then we went in and joined this all together. So I merged the two data frames that we had just made, the one for the share and the one for the release speeds. And now just with that, a few lines of code, we have a table with Shane Bieber's pitch breakdown, how many he threw, what percent, and what release speed. And obviously there's just a ton more you can do with this, but this is most of what you do in terms of using Baseball Savant. You kind of just use the code to get data how you want it, put it into tables, and then do plots and get the final numbers and things like that. So this is only the very tip of the iceberg, and again, it'll take you a little bit of time. You need to devote some time to learning the basics, and it'll be probably kind of frustrating at first, and a lot of it will seem like a different language. But yeah, it's really rewarding once you get it, and it really opens up a lot of doors for doing analysis and fun things like that. So it's been probably my main hobby over the last few years of my life, just learning Python coding and applying it to baseball data. It's been a lot of fun. So I'm glad some people are interested, and as always, I'm here to help. I hope this helps something. I'm not sure it will, but thanks.